Okay, so we're going to leave the configuration that we had for skill one connected just like it was. And all we're going to do is we're going to add an amp meter to our metering. And what we're going to do is take 4 different configurations of the DC generator, and we're going to record the voltage and current output based on varying loads that we work through. Now, I'll do 1 or 2 of these, and what I will do for you is I'll provide this data for you, since you're not actually in here doing this. And from the data that I provide to you, you will use that to create some graphs that you'll submit for completion of this lab. Okay, so let's look at what we've got. Where we are is we're looking at skill 2, and we're going to connect and operate a series generator. And I think probably at this stage, let me back this off and we'll zoom in a little bit and get a better look at our circuit hookup. Okay, trying to bring everything into the picture here. And as you can see, hopefully, everything is just the way it was from skill 1, and nothing has changed. We have connected this generator in a series configuration, and all that means is that the field is connected in series with the armature. And that's the conditions that we see in this schematic on figure 39. The 3-phase induction motor is in the same place, and it's of course called the prime mover. So anyway, this is the thing that we're working off of. And now all we're going to do is we're going to work our way through this series generator performance data, and just walking through different loads, and we're going to see what the voltage and current output is as we walk through those loads. Okay, so again, we walk through our safety procedures, our safety checkout, make sure that we've done all of that. Then he says to notify the instructor, you're ready to operate the generator. The instructor checks the connections, says make sure the rheostat on the resistive load unit is set to 0. That's here, and it is at 0. Make sure the maximum resistance, that assures that the maximum resistance is being set here. And then it says set the toggle switches A, B, C, D, E, F. It says to set the, according to the position, he says the toggle switches are all supposed to be down, except for the last one, which is supposed to be up. So A, B, C, D, E is down, and F is up, which means that it's closed. Okay, now that's applying a certain load resistance, and what we find out, he's just telling us that what we're getting when we're in that configuration is 100 ohms of resistance. Okay, so after we do that, the instructor releases the e-stop. Excuse me. Then I turn on the breaker. 3-phase motor begins to operate, driving the generator. And he says measure the output generator voltage with the digital multimeter, and record the voltage in row 1. And just like I said, we're just going to work our way through this thing. Okay. Now what I'll do is I've got some sheets here, and I'll just take this one, and these will be the sheets that you will be provided that will have the data associated with them. So first off, I should probably turn my multimeter on, and I'm reading a very low voltage. And then the other thing here, it says I need to get the output current. So this is what I want you to use whenever you're in the motors lab. I want you to use a clamp-on amp meter, which this is the jaws of this, and I just open and close it. And then whenever I'm using a clamp-on amp meter, what I want to make sure I do is I clamp that around whatever it is that I'm measuring. Any conductor that has current flowing through it has a magnetic field that's associated with it. And This thing is designed to sense the strength of the magnetic field and equate that to a certain current. And so the greater the current, the greater the field, you know, it's proportional. So first off, whenever I'm using this thing, what I want to do, that's the on-off button is on the bottom. I cut it off. I want to make sure that I'm measuring DC amps. I've got two settings. I'm going to go with the lower one, so I will get a little more level of accuracy. I want to zero it out. Okay, so I've got it zeroed out. And then since this is a series circuit, it doesn't matter where I connect it. I'm going to get the same reading because everything's in series, right? And we know from a series circuit that that's characteristic of it. And, you know, as I'm reading this, and I'll just have to call these out, I'm going to write them down for us as we work through this. And we're going to fill in the chart as we go. Let me do a quick pause. So what we want to do is record our voltage output and our current output. So I'll look at my voltmeter and I'm reading 6.1 volts. So I'm going to write that here. And I'm writing this with a Sharpie, so hopefully you can read it. Of course, what you would do in a lab, I'd want you to use a pencil so that in case you happen to make a mistake, you can fix that. And it says the output current. What is that in amps? So from my meter, I'm reading 0.06 amps. And that would be my first reading for 100 ohms of resistance. So the next thing says to take switches A through D, A, B, C, D, make sure that they are up. Hear the sound, the change on the generator as I went through the load variation. So I've got A through D, they are up, and E and F are down, and that's supposed to be giving me a combination of these resistors in series and parallel in this resistive load unit, and I would be at 92 ohms now. I've got a new voltage output to put right now. I got 11.7 volts, and my current now is 0.12 amps. Of course, if you were in the lab, you'd have a lab partner, maybe two, and you guys would all be working together and getting this data, making these changes. So now I'm ready for the next one, and I want, just do this, I'm going to say A, B, and E, and C, D, and F are down. I've got new readings to write down, and let's see, didn't exactly go the way I thought it might in terms of a consistent reading, so I'm going to recheck this. I've got A, B, and E up, and C, D, and F down. Okay, so I've got it right. And whenever you're in the lab and you've got everything set up right, just write down what you got. Don't try to make the numbers fit what you think it should be. So I've got 8.7 volts, and my current is 0.10 amps. I'm ready for my next one. Okay, for me, I like to start and just go start from the beginning. So I've got A, C, and E up, and then B, D, and F down. And for that particular configuration, I'm at 14.3 volts. Kind of got an outlier here, don't I, on the second one. 14.3 volts and 0.18 amps. All right, everything down, starting fresh. I've got for the next configuration, I want A, B, and C up, and E up, and then something hit. And I don't know if you noticed or heard that, but if you remember that saturation curve that we looked at, we finally got to an area where we're hitting that saturation curve, and you know, the numbers make this big leap. And so our voltage now is at 95.8 volts, and our current draw is 1.23 amps now. Okay, so we had that big jump when we hit the curve, And that'll be a little something for the discussion later. For right now, we're just writing the data down. Okay. Now, let's see what the next one is. I've got A, B, C down, and D is up, and E is, I don't have a little trouble reading this, up, and F is down. Okay, so now I've got a reading of 120.8 volts and a current draw of 1.86 amps. Now I would say this, when you start to draw current on this thing, you know, this resistive load unit will start to heat up after a certain period of time. Okay, this one has, for 50 ohms, I want E and F up and everybody else down. A, B, C, D down, E, F up, and now I'm at 128.5 volts and with a current of 2.21 amps. Okay. Next, I want B and E and F up. I want A, C, and D down. My new reading is 129.3 volts and 2.36 amps. Okay, get my table filled in as I go ahead. The next one, I want C, E, and F up, and I want A, B, and D down, which is what I have now. And what I'm looking at is 130.1 volts with a current of 2.53 amps. You know, now I'm starting to see a pattern across here. You know, every increase in load, an increase in load is equivalent to a smaller resistance, right? The load is increasing, and we see that the current is going up and the voltage output is going up. All right, now let's go to the next one. I want B, C, E, and F up, and I want A and D down. I'm at 129.8 volts. Current is 2.65 amps. All right. D through F up. A through C down. I'm at 39 ohms. And if you'll remember, that was the actual resistance we used in skill 1. And now I'm reading 129. Looks like I'm leveled off here. 129.8 volts with a current of 2.85. Current keeps increasing. Voltage is relatively unchanged. C through F up, A and B down. Voltage is 128. What's it saying? 128.0 with a current of 3.09. And then I've got one final one where B, C, D, E, F are up and A is down. And when I'm at that point, I'm reading a voltage of 126.9 with a current of 320. And now before we leave this, I just want to show you these actual meter readings. Okay, so here's the clamp-on amp meter showing us that current of 3.20. Varies a little bit, but at the time it was 3.20, it's 3.21 now. And here's our voltage output that we can read. If I bring that in there close enough, get the glare off of it, that's our output voltage that we're reading across there. Okay, now at this point we've got all the data that we need. So what we'll do is we'll shut it off, turn off the main power, and now we're going to take this data and we're going to create a graph of the data, and I'll show you the next stage of this. And like I said, there's several of these to do. We're just going to do a couple and be done with it, and then you'll have the data given to you. Okay, so now you would have proceeded through the reading or the e-learning portion of the next part of this, and now you're ready to do skill 3. And like I said, this will be the last one that I'll demo for you, because you're getting the idea of how we go about and collect the data and so forth and so on. I just want you, make sure that you're clear on that, and also show you the different connection schemes for the generator. All right, same machine, but what we're doing is it's connecting it in different configurations. So here's skill 3. It says connect and operate a self-excited DC shunt generator, which is something we talked about in class. And again, the AC motor is on the left side, the DC machine is on the right side, but we've got a little different connection scheme now. And of course, the AC motor doesn't change anything. It's just the prime mover that's causing the armature to rotate. But what has changed is our connection for the field. All right, so what we want to do, this is my recommended method for all of these. Don't try to modify an existing circuit. It's just best to start from the beginning, and you'll be less likely, I think, to make mistakes that way. So I'm just going to disconnect all my connection wires from here. And then what I'm going to do is go to the schematic diagram. I'm just going to pick a place and start. I'm going to start at C2, and I'm going to connect to A1. So looking on my template, I'm at C2 and told to go to A1. All right, so the interpole to the armature connection 1, come out of the armature on the output side to A2. And what I want to do there is connect to the shunt field winding, okay? It says connect to the shunt field winding, okay? Now, we didn't know this until, we got into the lab, but the shunt field is these two connections. This was the series field. So now we're doing the shunt field connection, which is, what we use for parallel operation, or the electrical term shunt. So I come out of A2, and be careful with this. Look, just come out of here and forget about this portion of this at this stage. Just follow this through. So I'm coming from A2 out to F1. A2 to F1. F1 to F2 is internal, right? I just want to follow F2 out, output side, connect that to C1. F2, output, C1 to the other side of the interpole. Okay. Then, let's see, from there, I've got the connection that I need to show for the resistive load unit. And we'll just be careful with that, make sure that we, there's a couple ways we could do this. We can come out of A2, or we can come out of F1. And as I look at the diagram here, it looks like he's connecting from A2 to the negative. So that's what we'll try to do here. We'll go A2, and again, it's in parallel. So I just plug in on top of that, A2 down to the negative terminal here. Okay. All right. So I went A2 to the negative, right? A2 to the negative. And then on the other side of this, I come out of the resistive load, and I lost a wire. So I'm going to have to pause and grab a wire. Hold on just 1 second. Okay, so I have the wire. Let me do it just like he's doing it. What he's showing here is he's showing the connection from the positive side of the load going into C1. You could also do it at F2 because they're connected together, right? So that point electrically is the same, but let's just do it like what he's done here. So we're going to take the positive side and we're going to come out to C1, which is ultimately here. It's also the same point electrically as F2 because they're in parallel. So here we go. We'll just go right in like he says to C1. 1. All right, now we've got everything connected, and then what we are going to do is just like we did before, we're going to be measuring voltage output and current. So let me get that all set up and we'll come back and finish this. Okay, now a little bit different with this circuit. When I had a series circuit, it didn't matter where I connected the amp meter, the clamp on. But with this, I don't want my amp meter here. I want it connected here. So what I think I'll grab this C2 to A1, C2 to A1 wire, and that will give me the opportunity to measure the current that I'm needing. So again, I'll power this up, zero it out. Okay, C2 to A1, and I'm going to clamp on right there and use that as my connection to measure the current. All right, now let me stop one more time and we'll run through this one. Okay, what I thought might be better for you instead of torturing you through another series of all those voltage and current readings, you get the idea. You're going through the different load settings and recording the characteristics of those load settings as you work through them. And so anyway, I won't go through that again. You're up to speed on that. And what I'll do now is I'll provide the data sheets to you for the 4 different configurations, which end up being skill 2, skill 3, skill 4, skill 5. And I think that's really it for this lab. That is it. So we're good. We've figured out what we would actually do in the lab. You're going through this with the Amatrol e-learning, and everything should be in place. Let me know if you have any questions on any of this. And again, I'm looking forward to getting you in here and actually working on this stuff.